Hey Nat5, as usual, got a starter here, 4 questions. I want you to pause the video, I want you to complete the starter and then unpause the video because I'm just about to go over the answers. Okay, so for question 1, what method of extraction would be used for the following ores? Now, tin oxide, if we look at this, remember we spoke about any metals, silver and below, you would just use heat. Gold, that's found uncombined along with like platinum, yeah. But silver and mercury, we would use heat alone. Anything zinc, copper would be heat plus carbon or carbon monoxide, and anything aluminium and above, we would use electrolysis. So for tin oxide, we would use heat plus carbon. Heat plus carbon or carbon monoxide, yeah, doesn't matter. And mercury oxide, if we look back at our electrochemical series, mercury is down here, not very reactive, so we would just use heat, yeah, that's enough. Gold, we don't need to do anything because that's already found uncombined, but mercury oxide, we would use heat. Copy and complete. Nickel plus lead oxide. Now again, this would be a type of displacement reaction, so we find nickel and we find lead. Now because nickel is higher than the lead, the nickel will be able to displace the lead. Okay, so this would become nickel oxide plus lead. Now this one, tin plus calcium, yeah, you'll see that the tin is lower down than calcium, so because it's lower down, it's less reactive, it's unable to kick it out, so we're not going to get a reaction for that one. Okay, question 3, what is meant by oxidation? Oxidation is the loss of electrons, and reduction is the gain of electrons. Yeah, remember oil rig, yeah, oxidation is loss, reduction is gain. Now write the oxidation and reduction equations for sodium. Now if we do the oxidation, yeah, it's just a wee fancy way, a shorthand way of writing oxidation. For sodium, in fact we'll do reduction first because that's a lot easier. Now remember again, you need your data book, okay, so reduction of for sodium, remember reduction reactions we just write as it is. So this would be Na plus aqueous plus E minus goes to Na solid. Okay, so Na plus aqueous plus E minus goes to Na solid, and that's the reduction. Yeah, that's it. Now for oxidation, all you need to do, remember what I said, all you need to do is flip the reduction. So the products become the reactants and the reactants become the products. Okay, so for this one, this would be Na solid going to Na plus aqueous plus E minus. Yeah, and that's it. That's all it is. Okay? Right. So our lesson today is metals lesson 3. And today we've done oxidation, we've done reduction, we're going to look at redox. Okay? So I'll give you a wee bit of background to it and then we'll jump straight in. So, in redox reactions, what happens is both oxidation and reduction, they happen at the same time. Okay, so both oxidation and reduction reactions happen at the same time. Okay, now this is important because you can't get one without the other. Okay, they're happening at the same time. You can't get a reduction reaction without an oxidation. You can't get an oxidation reaction without a reduction reaction. And we spoke about this last lesson, how redox is just a combination of reduction and oxidation, yeah, redox. Right, now this next part is so important. Okay, this will help us when we come to writing our redox equations. So metals higher in the electrochemical series. Yeah, this whole topic's all about the electrochemical series. So metals higher in the electrochemical series undergo oxidation, and metals lower undergo reduction. Okay, now you need to know that. Okay, so if there's a metal that's higher, it undergoes oxidation. If there's a metal that's lower, it undergoes reduction. Okay, that's the whole basis of this entire section. Okay, so it's very important that you know that. Now, what we need to do is we need to combine our oxidation and reduction equations together. Okay, now you've done this in third year, but if you've forgotten, don't worry. Okay, hopefully this sort of you remember it, like, oh, I remember how to do that. So to combine oxidation and reduction equations to give the overall redox, what we do is that we must first have equal number of electrons. Okay, equal number of electrons on either side, then we cancel the electrons out. Okay, now that might not make sense just yet, but it will make sense when you see it. Okay, so that's important. To combine oxidation reduction equations to get that overall redox, we must have an equal number of electrons on the product side and the reactant side. Okay, now the best thing to do is just to jump in and look at examples. Okay, so we're going to do 5 examples. So number 1, let's look at calcium and tin. Okay, so if we take calcium and tin, let me get my data book, we'll see that calcium is up here, tin is down there. So because calcium's higher, yeah, calcium's higher, so that means that that undergoes oxidation, and because tin's lower, that undergoes reduction. Okay, so we'll write that. So calcium is higher, therefore it's oxidation. Okay, and tin is lower, therefore reduction. Okay, and that's it, that's the first step. Okay, so important, that's the first step. So what you want to do now is you want to write the oxidation step. Now we're going to write this as a shorthand. Okay, I did this for the starter, that's just oxidation. Okay, the next one is reduction, and we're not going to shorten redox. Okay, now what I'm going to do, I'm going to take a ruler and I'm going to draw a line to separate my oxidation reduction from my redox. Okay, now the oxidation one is calcium. So if I take the data book back, we'll look at calcium. Now remember, because it's oxidation, we need to flip the equation. You need to understand oxidation, we flip the equation. So calcium solid is the reactant, and the calcium 2 plus the 2 electron, that's your product. Okay, so we're going to write that. So calcium solid, and that goes to calcium 2 plus aqueous plus 2 electrons. Okay, now the next part, this is probably the most important, is when you're doing this, I want you to write the arrows directly underneath each other. Okay, and you'll see why, because it's so important that you can establish what the left side is and what the right side is. Okay, so reactants, products. Now, if we do the reduction of tin, which is nice and easy because we find tin and we just write it out as it is. Okay, so SN2 plus aqueous plus 2E minus goes to SN solid. Okay, so SN2 plus aqueous plus 2 electrons goes to SN solid. Okay, now remember what we said up here, to combine oxidation reduction, we must first have equal number of electrons and then cancel them out. Now, on the right side, we've got 2 electrons, on the left side, we've got 2 electrons, so they're equal, so what we can do is we can cancel the electrons out. Okay, now once we've done that, if we look at the left hand side, yeah, we've got calcium solid and SN2 plus aqueous. So we write that. Calcium solid plus SN2 plus aqueous. Yeah? And then on the right, we've got calcium 2 plus aqueous and SN solid. So we write that. Calcium 2 plus aqueous plus SN solid. And that's why we have the arrows directly underneath each other, so you don't get confused. Okay, so the products on the right, we write on the right. The products on the left, we write to the left. And that's it. Okay, literally, that is it. So let's go over one more and then we'll make it a wee bit more complicated. Okay, so let's look at sodium and lithium. Yeah. Now, if we look at our electrochemical series, sodium is down here, lithium is higher up. So because lithium's higher than sodium, lithium undergoes oxidation, sodium undergoes reduction. Okay, so lithium, oxidation, sodium, reduction. Okay, so let's write out. So we've got oxidation, we've got reduction, and I want you to write it like this. Okay, this set up every single time, and we just separate the two like that. Okay, so for lithium, again, back to our data book, because it's oxidation, we need to flip it. Okay, so lithium Li solid becomes the reactant, then Li plus aqueous plus electrons, that becomes your products. Okay, so we flip the equation, so it becomes lithium solid arrow Li plus aqueous plus E minus. Okay, and remember, get your other two arrows directly underneath, and that's important, directly underneath. Okay, reduction for sodium, nice and easy because we just write it as it is. Okay, Na plus aqueous plus E minus goes to Na solid. Okay, so let's write that. Na plus aqueous plus E minus goes to Na solid. Yeah? Now, are the electrons equal? We've got one electron there, one electron there, ideal. Okay, so we can cancel them out, and all we need to do is everything to the left, so that's the lithium solid and the Na plus aqueous, we write to the left, and the La plus aqueous and the Na solid, we write to the right. Okay? just like that. Now, I often get asked the question, does it matter what one you write first? No, it doesn't. Okay, if you were to put Li solid there, that's fine. If you were to put Na plus aqueous there, that's fine. As long as they're both to the left of the arrow and the ones to the right are both to the right. It doesn't matter. Okay, now, obviously it does get harder on that. Yeah, so what happens when the electrons are not equal? Okay, what do we do if they're not equal? So, this is going to be example number 3. So let's look at potassium and magnesium. Okay, so potassium and magnesium. So magnesium's there, potassium's there. Now because potassium's higher, potassium's oxidation, magnesium is going to undergo reduction. Okay, so potassium is going to be oxidation, magnesium will be reduction. Okay, so let's start, get our equations ready. So oxidation first, reduction, and then redox, like so. Right, you can get your 3 arrows down straight away if you want. Okay, now let's look at potassium. That's the oxidation. Potassium is here, so that's that equation there, and because it's oxidation we need to flip it. Okay, so the K solid on the left and then the K plus aqueous plus electron, that's on the right. Okay, so K solid goes to K plus aqueous plus an electron. Okay, and the magnesium, nice and easy, reduction, we just write it as it is. So Mg2 plus aqueous plus 2 electrons goes to Mg solid. Okay, so Mg2 plus aqueous plus 2 electrons goes to Mg solid. Now, hopefully you'll see that the electrons aren't equal. We've got 1 electron on the right side, 2 electrons on the left. So what we need to do is we need to multiply the equations in order for these to balance out. Okay, now a wee trick you can do is you can just multiply the electrons by the other one. So 1 electron there, we would multiply that by 2. 2 electrons there, we would multiply that by 1. Okay, now this is important. If you're multiplying the electrons, you have to multiply the full equation. Okay, so the oxidation equation, we're going to multiply by 2. Okay, and it's not just the electrons that multiply by 2, it's the full equation. So a 2 goes there, a 2 goes there, and a 2 goes there, because we've multiplied it by 2. Now we don't need to multiply the bottom one by anything, and hopefully you see that the electrons now can cancel out. Okay, now that electrons have cancelled out, it's the easy part, we just write it as it is. So the reactants there, you write here. The 2 products, you write there. Okay, so that's 2K solid plus Mg2 plus aqueous, and that goes to 2K plus aqueous plus Mg solid. And that's it. Yeah, literally that's it. Okay, we'll do 2 more. Let's go for silver and copper. Okay, silver, again if we just look at this, copper's here, silver's there, so because copper's higher, that's oxidation. And because silver is the lower metal, that is reduction. Okay, so set up our equations. Oxidation, reduction, redox. There it is. Okay, oxidation is the copper. So here's the copper equation there. So all we're going to do is flip it. Okay, so copper solid on the left, copper 2 plus aqueous plus 2 electrons on the right. And you can get your 3 arrows directly underneath each other. So copper 2 plus aqueous plus, oh sorry, that's wrong. We're flipping it, so that's copper solid goes to copper 2 plus aqueous plus 2 electrons. Yeah, reduction, the easy one, silver, we just write it as it is. Okay, so that is Ag plus aqueous plus an electron goes to Ag solid. Okay, and you can see the electrons aren't cancelled out. So you can times that one by 2, that one by 1. Okay, so let's times the reduction one by 2. Okay, and remember it's the full equation we're timesing by 2. So a 2 goes there, a 2 goes there, and a 2 goes there. Now finally we can cancel the 2 electrons on either side, and we just write our reactants to the left, so that is 2 Ag plus aqueous plus copper solid, and that goes to 2 Ag solid plus Cu 2 plus aqueous. That's it, literally, that is it. Now let's do one more. Let's go for aluminium and nickel. Now, this is probably the hardest one you'll get, okay, and even then, it's not even hard. So, aluminium and nickel. Aluminium's here, nickel is there. So because aluminium's higher, hopefully you're getting this now, because aluminium's higher, that undergoes oxidation. Because nickel is lower, that's undergoing reduction. Okay, write out our equations, oxidation, reduction and redox. And here we go, just take your ruler, like so. Okay, aluminium, you can get your 3 arrows up already. Okay, so aluminium's oxidation, so we flip it, yeah, Al solid over here, Al3 plus aqueous plus 3 electrons onto the right. Okay, so Al solid, that's going to be Al3 plus aqueous plus 3 electrons. Okay, nickel, the reduction, nice and easy, we just write it as it is. Okay, so that is nickel 2 plus aqueous plus 2 electrons goes to nickel solid. Okay, now you'll notice we've got 3 electrons and we've got 2 electrons. Now we can't just times one of the equations, okay, because if we times that by 2 we're going to get 4 electrons. That's not going to work. Now remember what I said earlier on about the wee trick, is that one you can times by 2, and then this one you can times by 3, because we're trying to find a common denominator, and that common denominator is 6. Okay, so if we times the top equation by 2, we would get 2 ALS, 2 Al3 plus aqueous plus, score that out, we're getting 6 electrons now. Okay, and if we times the bottom one by 3, yeah, that's going to be 3 nickel 2 plus plus 6, 3 nickel solid. Okay, so the common number they both share is 6. So what we can do is we can cancel them out. And that's it. It's the same thing over and over. Okay, so everything to the left of the two arrows we write here. So that's going to be 3, doesn't matter the order, 3 nickel aqueous plus 2 Al solid. And then everything to the right of the two arrows we write here. Okay, so that's going to be 2 aluminium 3 plus aqueous plus 3 nickel solid. Okay, and guys, that's it. Okay, so what do you need to take away from this? Well, you need to take that the metals higher undergo oxidation and the metals lower undergo reduction. Okay, and the whole point, to get the redox, we need to cancel them out. The electrons have to be equal. Okay, so before we start doing any cancelling, the electrons have to be equal. Okay, if they are equal, that's nice and easy, just cancel them straight out. But if they're not, you need to multiply the full equation, manipulate it in order for that to work. Okay, so this one here will multiply by 2 in order to get 2 electrons so that we could cancel out. And guys, that is it. Okay, very easy. It just takes a wee bit of practice. Okay, so I'm going to put up some questions on Teams for us to do. Any questions, just let me know. But for us, that's it. So thank you.